Good day, everyone. Last couple months, I have been working on a project where I need to do full disk encryption, including boot partition, also enabling secure boot, but using TPM. So these are all major subjects that I learn as I go, and therefore today's presentation is not going to be deep dive. Mostly it's a brief introduction, those subjects, and my focus on this mostly hands-on. So I'm trying to show you, guide you, how you will have installed those on your Linux environment. And I would like to start with refreshing our memories on how Linux boots up. So you may have the device you turned on, and there will be initial check takes place. Well, you may not have necessarily monitor, keyboard, mouse. You may be accessing via KVM, but it will check whether there is any bootable storage device. And after that, for instance, this storage device could be hardware, where hard drive where the Debian is installed with group bootloader. So bootloader will be loaded. After that, kernel, init RAMs, and so on. And after that, user space will be available for us. But there will be one more, or maybe initial check during the early boot, using the Secure Boot. It's mostly a verification. What is that? What Secure Boot does? It's basically serves one purpose only, which is validates the integrity of the bootloader and also prevents unauthorized modification. And how can it do that? Basically, it uses cryptographic keys. And there are two approaches to do this. One will be, we can call it as like a common one or standard one, where we can have little bit power on customization, but the keys will be already generated, and we just don't own them, we just rely on them. So all the EFI binaries will be signed by those keys, which are platform key, key exchange keys, and also authorized signatures, which is the DB. Here, as I said, we have a little bit like place for customization, but we just rely on the existing system. The second approach, however, where we not only do a little bit customization, but we can wipe out all the keys and then generate our own ones. This will give us the basically whole power of the trust chain, that's what we called. And if you can just look at this diagram, where I try to present how these two systems work compared to each other. So one thing you may just realize that shim doesn't exist on the second one, where we are owning the keys. So basically what happens, shim is verify the group and so on. But when we are owning the keys, we can basically exclude the shim, and our signed keys will take over and handle the verification process. So right away, I will jump in how we can actually set up this on our Linux environment. Well, we need to, of course, install a few packages. But one important thing here, right away or even before install those packages, actually, you should do after that because you need to have the mock-util installed on the system. You need to check the state of the Secure Boot. Because you need to later on enroll these keys, and if there are already keys there, you may not be able to enroll them. You may get an error message, or maybe there will be multiple keys enrolled. So in order to prevent that, you can check whether the Secure Boot is disabled, and also check the status. How we can check it? So there are different systems out there, and you just need to find where the Secure Boot is located and disable it. And after that, you need to go and delete all the keys: platform key, key exchange keys, authorized signatures, and also you can delete forbidden signatures as well. After that, what are you going to do? Well, it's actually quite straightforward. You need to create the keys along with the certificates. Then you need to convert the signature list. After that, you need to sign them. And if you wish, you can also create the DBX. This is the revoked list. Prevent some malicious software to be run on your operation system. We may talk about it later on a little bit more briefly. So after that, you need to sign the kernel. There is a question mark over there. I just put it because we may have multiple kernels there, so you can basically maybe even automate this process using a bash script or even Ansible playbook, which will sign all the kernels. After that, you need to sign all binaries. So I have already mentioned that you can actually exclude the shim, but I'm still experimenting. So you may just sign all the binaries and see whether it will have any impact or whether it will not make any difference and system will just boot up securely. One thing I can mention that these AFI binaries may come with already signature in them. So that's why you are kind of creating an empty one, and then you are signing them. So you will just have your own keys on them. The assumption is that I already have one signature on each AFI binaries, and you are removing each. So after that, there are two ways you can actually enroll these keys to trust chain. One is you can use the EFI update war, and the other approach will be placing those keys in certain folders and then using the SPE key sync, which you need to run 2 times. At first, it will enroll key exchange keys and auto signatures, which is a DB, and the second one will be for the platform keys. After that, basically you will reboot the machine, go to UEFI again, and enable the secure boot. And everything goes well, your machine will boot it up securely. But what we have doing so far is just securing the boot process. What if or data? Well, on Linux, there are already implemented systems that we can use benefits of to encrypt the storage device. One of will be a Lux, for instance. This is kind of widely used, and if I'm not mistaken, it's built on the Encrypt. It comes with the various options we can use. I am going to go through again how we can actually set up this on your Linux environment. So let's say there is a partition you want to encrypt. I recommend to wipe it out and be sure that this is the partition you want to encrypt, because we are going to wipe out everything there. So yes, you don't use 1, 2, 3, 4, 5 as a password. It should be more convoluted things. And this is just for the presentation, of course. But the purpose is here. You can use crypto setup to encrypt the partition, then open encrypted partition. After that, you format that partition with the type format you wish. One important step here that you should not never forget is adding this decrypt tab. If you don't add this, the operation system will not prompt you to unlock this device. Actually, there will be another slide will make more sense when I get there in a moment. And the second important thing is, please don't forget update the intrams. If you don't do that, you may get kernel panic when you are rebooting the system. In most cases, I hadn't had any issue system boot up, but I mean, let's don't risk it. This is just a partition on your system, right? But what if you want to encrypt the root, like a whole system maybe? And then I recommend not to use a live ISO or something. Just do it during the installation process. I am not going to deep dive on that, but you need to find the certain options during the graphical installation or any type of installation, could be unattended too, and you need to encrypt the partition here with your desired options. So, as I said, after reboot the machine, you will be prompted to enter the password, because you already put this in the crypto tab. Now the machine, in other words, operation system knows there are encrypted hard drives, so you will be basically asked to enter the passphrase for each. But what if you want to automate this process? You don't want to enter the password, right? So in that case, we can generate a key file. Again, you can generate in various different ways. This is just one way. And after that, you can add this key file using an encryptor setup, and you must come to crypto tab and now update to the one section. Previously, there was none, looks discard, and now we are adding 2 more things. We are just removing the none, adding the path to the key file, and also we are defining the key slot, because we at this point know that the key file will be in the slot 1, which will make much faster for system to actually unlock using the key file. And again, we touch the crypto tab, we must still update to init rams. So, what if you want to take a little bit like a further and take a journey and encrypt the boot partition? So this is where the whole fun begins. Debian, I guess the recent version is 12.9, comes with group 2.06, which doesn't support auto unlock. You need to upgrade the group version 2.12 or 2.13. And you can only do that, so far I found, just pulling the repo and building the group from its source code. It is a little bit tedious process, but so far it works. There are more options here available. I just put there for you to have for you to just see it. You don't need to put them. You can also work with default values. But one important thing is that Lux1. To my knowledge, group doesn't support Lux2, so it may not be able to interact and unlock the boot partition if it's encrypted Lux2. So it should be Lux1. And after that, there are similar steps. You need to basically open it, format it. But one important aspect here, if it is the boot partition, I recommend you do first back it up and then remount it as not readable, only read-only, because there should not be anything read-write at the moment. just to protect the integrity of the boot partition and the data. And then later, you can actually restore. And now you need to go to fstop this time, as well as the crypto tab again. That part is, I guess, not here, but you need to also update in the crypto tab. But here is, again, you need to define the, change the, by the way, the partition name, because it was maybe dev stba1, and now it will be the encrypted one, because you are now booting up from the encrypted one. So, this is not all. You need to also must do now install the group, because you already intervene with the group. So you change some stuff and you have to install the group install. But if you do that, it will fail. It will actually give you an error message because boot is encrypted, which is why you need to also go etcd default group, and you need to basically set the group enable cryptography as yes. And after that, you can generate the configuration and you can install the group. At this point, it is not automated, but group boot partition is encrypted. So what will happen if you boot up the machine? You will, at early boot, as soon as the machine is boots up, you will see some like names, colors, hard drives found. Right away that moment, you will be prompted to enter the passphrase for the boot partition. But what if you want to automate that too? In that case, am I missing one slide here? Install group. Yes, if you want to unlock that one, so you have already installed the group version, which supports the automated unlock. So first thing you need to do, you need to change the group configuration. Under the boot EFI Debian, or could be Ubuntu maybe on your operation system. So you need to find the right one. And there are two question marks here. The reason is because I kind of forgot to update them. The crypto mount will target the encrypted partition. And the second question mark is actually what will be named after it is decrypted, because operation system find the group there. So when you have this configuration, what will happen? Basically nothing until you build your own EFI. So basically you are having this configuration file and baking into the EFI binary. And after that, when you reboot the machine, if everything goes well again, then you will not be prompted anymore enter the passphrase, but the group will just tell you attempting the decrypt master key, and then just say slot 1 is open, and then the rest of the boot process will take over. So far we have been talking about software-wise actually security measurements, boot enable secure in boot, and also the encrypting data on the partitions. But what about the hardware-wise, actually, the security? So TPM is actually one of those solutions. It is basically enhanced data protection on your devices. It might be there already on your main board. If it is not, you may check it, whether you can actually have this module and edit there. Module might be there, but it might not be active, so you can go UEFI and you can check whether it is there and it is on, whether it is founded. So my goal is to today, again, show you how you can actually interact with the TPM. Based on the assumption that you have it on your device and it is on and it is working. But of course, if you want to interact with it, you may need to install a couple of packages on the operation system, starting with the TPM tools, and after that you can check the version. All these commands here seem to be working with the version 2, which I tried yesterday, just to be sure. So you can check the version. The second command is a little bit simplified. I put a couple more additional command there, because when you run it, it will show you also how each process, how long each process took time. So I just removed that. So basically, you can get more data about your TPM chip. Again, you can also use other commands to see, gain more information. This might be maybe valuable. One of your projects, maybe you will do. You need some specific information. Again, you can also use TPM own commands, TPM to get cap, to learn more about your TPM device. So you have the TPM and you want to interact with it. So right away, I will suggest you to own the TPM. What gives you, this actually give you benefits to create a password, which is stronger than this one. But later on, when you are sealing and unsealing data, you might be actually asked to enter this password, which is beneficial because if anyone accesses the operation system, a user, for instance, may use a TPM chip and unseal the data, unless they have the password, you won't be able to do that. So there is a simple example. You are creating a primary key, and you are actually providing the password, and then you are creating sealed data, and I just want to emphasize this. Data is sealed, which means the data you have might be already an encrypted key. So you are not re-encrypting it. You are just sealing this data and then placing in the TPM's memory. But if you load it, it's not going to be a persistent. It will be in volatile memory. So if basically reboot the machine, that data will be gone. Which is why we are running the AVC control command to have it persistent. And when you see this prompt on CLI, that it will indicate that on that address you have your persistent handle. And you can actually list whether there is anything already persistent. And if you want to unseal, you can basically just use TPM unseal and target that specific address, and it will be sealed. But if you want to also evict it, you can basically, again, use your password, and then you can target the address, and the data, which was previously persistent, will be evicted. So there is more to TPM. You can also work with policies. Why you can use policies? Basically, you can make this sealing and unsealing process a little bit more challenging. And also, these policies has benefits. For instance, there are, I guess, 15 to 26 policies exist. And you can also get these lists online. And one is, for example, 7. 7 is about the secure boot. So if you use the 7 as a policy with your TPM integration, if you go somehow, some person access the UEFI, and if you disable the secure boot, then if you have other security measurements is done, placed with the TPM, and then TPM say, I am not doing anything, I am not unsealing any data, I am not letting any key go because some person tamper with the secure boot. 0, 1, 2, 3, 4, these are for the hard drive things. For example, if some person remove the hard drive, there could be RAID, multiple hard drives up and running, and then TPM will still complain about that. So I'm going to speed up a little bit here. So again, these are how you can work the policies. You can basically create a session, and during that session, you can unseal and seal data, and then you can actually then flush that session. Okay, so this is the kind of most important part that I would like to talk about. So let's say you have done all of this. You have the secure boot enabled, you have the group partition encrypted, and then you want to do one more thing, which is you want to automate this process. Or you want to use the TPM during the just early boot. So you can use the configure the init RAM for this. So there are two places you can put a custom script. One is actually the hook place. Here you can configure the script which will basically copy executables binaries in the init RAM. So you are just defining what type of binary, what binaries you like to have there, and then you are creating those directories. And dester is something is not a variable. You must have it there. This is the init RAM stuff. So if you don't have it, it may not work. It will not work actually. It will not find the file. So basically, we are telling it these etc keys must exist in the init RAM, and you want to have these binaries exist in the init RAM space. And after that, you may have another script. So the first one was the preparation. Second one, where you can do all your magic. So here, I am actually kind of emphasizing this script should run after the hook is executed only. There is some conditions over there. And after that, what I can do, because I have already binaries there, I can, for example, find a USB drive where I may have a public key. A public key must be signed and generated, and I may use it, for example, with the TPM. So here, I can actually look at that public key. I can find it. I can first check whether the USB drive exists, whether the public key exists. I can do some other checks. And after that, I can basically use that public key with the TPM and unlock maybe a drive. And you can also have a fallback here. Let's say things didn't go well. There was a public key, but the data was corrupted, but something didn't work out. You can actually still fall back, and you can still use crypto setup, for example. And if your whole purpose here basically to unlock the encrypted partition using the TPM and with the public key, and if it didn't work out, previously we have seen a prompt, please unlock the drive. So you need to get there. But you are already in init RAM, and you cannot go further. In order to get there, you basically force the system to prompt, so you will be able to enter the passphrase again. This is just a fallback. If you have like a production system, maybe you don't even do that, and you just need to maybe go there, intervene with the system physically. But after any of these are just script files placed under certain directories. Because this is the init RAM, you must definitely update the init RAMs, and if you don't do that, if you reboot the machine, most likely nothing will happen, but just we will not see any change. So pretty much, this is what I would like to cover today. Thank you for all. I think we have a couple more, 3 minutes for questions, or for the also come for more questions. Okay, so this is actually pretty much what I would like to cover. If you wish me to elaborate any other aspects, you can maybe just point at, then I can tell. Otherwise, that's all from my side.
So
Question?
for the questions, let me go with the microphone.
Radek Zajíc, thank you for the presentation. I have a question regarding the sealing part. Do you somehow pre-compute the hashes that you seal against? In this case, that would probably be the group part, because if you don't do that, an attacker could perhaps replace the binary with their own. Or how do you seal the data? What do you seal it against?
What do I seal against?
Yeah.
Okay.
Because TPM has like multiple registries, and each of those contain different hashes based on the boot stages, like the UEFI stage, the hash of the partition, the hash of the bootloader that UEFI loads, and so on and so forth. So if this is something that you have somehow been diving deep into.
If I understand, you are trying to ask. Not sure actually if I understood correctly, but I will tell this one. If you use a TPM just like how it seems here, you can just unseal it. You can do it without even password too. But in order to prevent any like maybe hashing replacement or something, I rely on policies. And there are other files here. This is not like a production at the stage. On production at the stage, for me, there are other TPM modules, binaries I am using, and they require external file, which is already been signed. And I also check the signature in advance. So if I don't have that file present on USB drive, for instance, which I was trying to present, and then system will not work. So I'm not sure this is answer your question. Clearly not. Okay, we can talk in later. Maybe I didn't understand.
Do we have any other questions? Nobody?
Nobody?
So